Welcome to ProgrammingKT. Today in this tutorial I am trying to explaining about collections concept in Java. So collections are used to store group of objects. So before explaining about collections, let me explain about the problems without collections. So if I want to store array of 5 elements, I need to declare 5 variables, right? So I can declare like integer I1, 10, integer I2, 20. Like this I need to create 5 lines of code, 5 variables, 5 integer type of variables I5, 50, like this. So for creating 5 variables, 5 lines of code is required. This is the problem. So to overcome this problem, first arrays are introduced. So what is array? Array is collection of homogeneous elements and fixed size. Homogeneous is nothing but same type. So we can declare array, integer array, new integer array. We need to specify the size at the time of declaring array itself. At the time of declaring itself, we need to specify the size. Now memory will be created array with array size 5, right? So 10 memory location, 5 memory locations will be created from 0 to 4. 1, 2, 3, 4. Like this memory is created. Once you create the array, then you can assign the values like a of 0 is some value 10. Like this you can assign. A of 5 is so a of 5 is 50. Like this you can store. So instead of creating 5 lines, 5 integer variables, we can declare at only one time, then we can assign it to corresponding arrays, locations, array index. You can assign the value by using array index. So this, to overcome this problem, arrays are introduced. With arrays we can achieve this in only one line instead of declaring 5 times. So the problem with arrays is, in some cases I want to store greater than 5 elements. In some cases I want less than 5 elements. This is the problem. Array size is fixed. So that is the problem. Array size is fixed, right? At the time of creating we need to specify. Then we can't increase, we can't decrease. This is the problem. So this is the first problem of without collections. This is the second problem with arrays. So to overcome these two problems, collections are introduced. So array can't increase, can't decrease means, so in some cases I want to store 6 elements or 7 elements. In sometimes I want to store 2 elements or 3 elements. In that case, if I want to store 7 elements, so I need to create one more new array with size 7. 0, 1, 2, 3, 4, 5, 6. Now this old array I need to copy here, from here to from 0th index to 4th index. So I need to copy, and new elements I can store here. So this is the problem. We need to create new array and copy old array elements into new array, then add new elements. This is the problem. We need to create new array. So in some cases I want to store 3 elements itself. In that case, last memory location is wasted. So in that case, I need to create array size with 3, and again I need, anyway we can ignore last memory location, right? An array of size 3. So this is the problems with arrays. We can't increase the size, we can't decrease the size. Size is fixed. So to overcome these two problems, collections are introduced. Now let me try to write the definition about collections. Definition and explanation I will explain. So definition is nothing but collections are used to store group of elements. Collections are used to store group of elements. So this is the definition. So before explaining about collections, we need to aware one more topic, generics. So generics are used to provide type safety and type casting. So generics are nothing but when you are trying to create list, set, map, these kind of implemented classes or interfaces, you may find that symbol called this kind of symbol, less than, greater than. This is called generics. Inside that you may find some characters like t means type, k means key, v means value. These kind of letters you may find. So generics are introduced to provide type safety and type casting. To provide type safety and type casting. We don't need to typecast. Auto boxing will apply. Typecasting. So this is the two. First is definition, second is generics. Now let me try to explain about collections. So collections may be. Collections will divide into three major categories like list, set, map. These are the three categories. So first one is list, second one is set, list, set, third one is map. These three are the major categories inside collection. Now let me try to explain about hierarchy. Hierarchy of the collections. So first two comes under collections only, under iterable, but map is separate. Now let me try to explain about first list and set, then I will explain map. So in this video I will cover only list only. In coming videos I will explain about anyway list and set and map also. Now let me try to write the tree diagram about collections hierarchy. Let me try to move little bit up. So for collections, root class is iterable. So in Java, in entire Java, root class is object class. In exception handling, root class is throwable. In collections, root class is iterable. These are the some important points you need to remember. So now I am trying to write the collections hierarchy, tree diagram. So root class is iterable, which is having method called iterate. That method is used to access the elements from all collections. So iterable. So iterable is the interface, root interface. Next one is iterable is a interface, not class. Next one is collection. Collection also interface. Next, from this collection we can divide into three types. First one is list. List also interface. List. Second one is set. Set also interface. Next one is queue. So list is from, list extends collection, set also extends collection, queue also extends collection. So all these are the interfaces. Now from list, implemented classes are array list, array list, and one more is linked list, and one more is vector. So whenever vector child is stack, and set implemented classes are hash set, and its child class is linked hash set. And one more is navigable set, navigable set, sorted set, tree set. And for queue is priority queue, priority queue. Anyway, queue also implement linked list. So these are the collections hierarchy. I mean, what is the root class? I mean, not a root class, you can call it as interface, iterable, having only one abstract method called iterate. By using that iterate method only, we can access elements from these collections one by one. So iterable, and its child next interface is collection. From that collection, again three major categories: list, set, queue. So list interface implemented classes are ArrayList, LinkedList, vector. So anyway, vector child class is stack. Then set, hash set, linked hash set, navigable set, sorted set, and tree set. Anyway, queue implemented class priority queue. Linked list also we can implement for queue. So under priority blocking queue, array queue, DQ, these kind of child classes also there. So anyway, when I'm writing the code, I will explain. So now let me start with array list. So now in this video, I am trying to focus on only list and its implemented classes. Now let me try to explain about array list. Let me start with array list. So array list, when to use, and internal implementation data structure, and null values are allowed, and what are the methods present inside it, and this kind of stuff. Let me try to explain with some points in array list. So array list, so first point is internal data structure for array list will be growable array. This is the first point you need to remember. What is the internal data structure is for array list is growable array. So what is the default capacity of array, I mean array list will be 10. And the next one is null values allowed. These are the some important points you need to remember about array list. So what is array list? Array list is implemented class of in list interface. So array list, some points about array list is array list internal data structure is growable array, capacity will be 10, null values allowed, insertion order is allowed, insertion order is allowed, duplicates allowed, and when to use. I mean, best choice is if your frequent operation is access. So best choice when to use. So frequent operation is accessing elements from array. I mean array list. So if you have collection, your frequent operation is accessing elements from the collection. In that case, array list is recommended. When I am explaining about difference between array list and linked list, I will explain in detail. So when to use array list, if you have requirement to store the elements, I mean group of elements in one entity, and frequent operation is accessing. In that case, recommended collection will be array list. Frequent operation is accessing. Frequent operation is accessing. Then use array list. So these are the some important points about array list. So now let me try to explain about why frequent operation, I mean best choice is if frequent operation is accessing. So if you have array elements, then the performance will be very fast. Why? Because random access is possible. So if you have internal data structure is growable array, right? If you are trying to store the elements inside array, so directly we can access, right? By using that index number, we can access 1 2 3 4 5. So if I want to access fourth index elements, directly I can access a of 4. So immediately it will go to here, and if the value is there, it will access it. There is no sequential access, it is random access. This is also one point, random access. Elements accessing order will be random access. If you want, you can sequential access also. If you want to access elements from 0 to end, you can go for from start to end. If you want to add any one random element, that one also possible. That's why I said here one point, random access also possible. So now you may have doubt. Here it is the array, right? How it will increase the size and how it will decrease the size. So that's why here the point you need to remember, growable array. Depending on our requirement, it will increase the size. So if the size will be, you created array list. So array list of integer L new array list. You can create object for this. So once you created this, default capacity is 10, right? So array is created with default capacity with 10 from 0 to 9. So this is the default capacity. Array is internally created like this. Memory is allocated like this for array list. So once you add L dot add of, add is the one of the method to add inside that element inside that array list. I am trying to add one. Like this, if we can add 10 elements, I mean L dot add of, L dot add of 10. Now at the time of inserting 11th element, L dot add of 11. So in that case, you don't need to create new array. So collection will maintain. That is the advantage of collection framework. So it can increase, it can decrease. So depending on our requirement, right? So now it will create one new array with default capacity, I mean new capacity. So at the time of here, if you don't provide any constructor, I mean value, I will show you when I'm writing the example in code, I will show you what is the capacity and how we can override this capacity. If it, default is 10, if you want to override 10, you can create at the time of creating itself, here you can pass the value 10, you can pass, I mean 10 is the default. If you want to 20, 20, 50, 50. So 50 is the now memory will be allocated with 50 locations. Default allocation memory, once you provide 50, now 0 to 50, like this it will be created memory for array list. So for 10 default capacity, I am trying to explain. So once the 11th element is created, I mean you are trying to add, it will create a double of the array. So previously it will be 10, right? Now it will be created with 20, memory size will be 20 from 0 to 19. Like this memory will be allocated, this is the 20th element. So size is doubled. Previously from 0 to 9 will be copied into previous, I mean new array, then this array will be removed from the memory. This is the new array. If it is pointing to L, previously it is this one. Once the you are trying to add 11th element, one more new array will be created with double size, 10 times 2, I mean 20, array size with 20. So now 20 locations will be created. Now this old array will be removed, the now pointer will be pointed to new array. So once we delete L dot remove, so delete remove, if you are trying to remove any one element, now again this 20 will be shrinked to 10. So previously it will be 20, right? Now again it will be create new array. Now all these new elements, 10 elements will be stored into array with 10 size. So this is the shrinking I can call. So increasing and decreasing internally maintained by collection framework itself. So that is the advantage of collections. Depending on our requirement, once you add the new element, it will increase it. If you are require, I mean if it will, I mean the size will be less than that threshold value, then automatically it will decrease. So that is the advantage. So this is about array list. Internal data structure is growable array. Array will be increased, array will be decreased depending on our requirement. Best choice is frequent, if the operation is frequent access. So this is about array list. Next one is linked list. So linked list internal data structure is doubly linked list. So next one is linked list, right? Linked list. So this is some points about linked list is internal data structure will be doubly linked list. Double linked list. So double linked list is nothing but you have nodes, right? One will be data node and one, node have two parts. One will be data part and second will be link part. So we have two links like this, forward link and backward link like this, doubly linked list. Previously, array list internal data structure is growable array. For linked list, internal data structure is doubly linked list. And same rules applicable for linked list also. So duplicates allowed, null values allowed, and insertion order allowed, except internal data structure remains, I think, all, possible. And moreover that array list and linked list, these are the not thread safe. So more than one thread can try to change the value, that's why these are the not thread safe. So insertion, null values, duplicates, internal data structure. So when to best choice, so best choice is frequent operation is insertion and deletion, insertion comma deletion. So there is no default capacity here. Why? Because this is the internal data structure is linked list, right? Once we create, it will add new node, but we can't guess the capacity, right? That's why there is no default capacity. So here, once you create the linked list, I can create list. So we can create, reference will be parent class, right? Either it may be class or interface you can provide. List of interface, integer data type I am trying to consider here. L, new, linked list. So linked list, this is the, once I add L dot add of 10, now one new node will be created, like value is 10 and next point, pointing is to null. So once I add L dot add of 20, now this instead of null, it will be pointing to next node. It will add one more node, like, so this is the point forward pointer. Next one is the, let me try to remove. So 10 head, this is the head node. So one will be data part and the next one will be the link part. It will have link like this. And second node will be 20 and pointer is null. This is the head node that is pointing to L. Now if we are trying to add one more element, L dot add 30. Now again null will be removed. At last node will be 30, forward pointer, backward pointer, like this. So why? Because in best choice is insertion and deletion, linked list is recommended. Why? Because if you are trying to delete the 20 element, element 20, so simply if we can remove the node here, then directly forward pointer will be like this, backward pointer will be like this. So middle node I deleted, I will remove the, instead of that, for understanding purpose, so I will break the link here, directly I will pass link to this node, and this forward reference node I will pass to here, this node, like this. Now this node have don't reference, forward reference and backward reference, that node was deleted. So that is the advantage with, there is no, insertion and deletion time is. So if this is called deletion. Insertion also simple. So if you want to add element, again let me try to create one more node here, 40, forward pointer, backward pointer. So I want to add element 35 between 30 and 40. So simply what I need to do, I will create one node 35. So this forward pointer I will assign to 35. So then this backward pointer I will assign to 35. So now this link will be, I mean link I changed to 35, and that 40 previous pointer I assigned to 35. Simply this is adding, this is removing. That's why insertion and deletion is frequent operation recommended for linked list data structure. So this is the one point you need to remember: when to use array list, when to use linked list. This is the first point. And moreover, that internal data structure of array list is groupable array. Internal data structure of linked list is doubly linked list. When to use array list, when to use linked list. And some methods. Anyway, methods: add all, add first, add last, remove, add all. I mean, n number of methods are there. When I am writing the code, I will show you that what are the methods exist inside array list and linked list. So next one is vector. So vector is legacy. I mean, all methods present inside vector class is thread safe. For array list and linked list, methods exist inside that array list and linked list is not thread safe. For vector class is thread safe. Now let me try to create a vector. Also remains same except thread safe. I mean, vector is thread safe and remaining array list and linked list is not thread safe. Remaining rules are same. Stack also, stack is nothing but have some different methods like push, pop. Here for array list and linked list we have methods like for adding, add will be there, removing, remove will be there. For stack, stack is a LIFO, right? Data stack is LIFO data structures. LIFO means last in first out. So for adding elements we can call push. For removing elements we can call pop. So these are the two major push, pop, pull, peek, peep. These kind of methods will be there. When I am writing the code, I will explain. So vector is thread safe, legacy collection. So this is about explanation about list interface and its implemented classes: array list, linked list, vector, stack. So when to use and some points I explained. Now let me try to explain about all this. I mean, array list, linked list, vector, stack in IDE with an example. Now let me try to explain about list interface and its implemented classes like ArrayList, LinkedList, Vector, Stack. So for that I already created here one list package. So inside that I created one file called ArrayListExample.java. So for time saving purpose I already created some important points about ArrayList. So let me show you the documentation about list. Then I will explain one by one. I mean, anyway, at the time of showing documentation only. So I will explain what is the default initial capacity and duplicate elements are allowed or not. I mean, yes, duplicate elements are allowed. So null values allowed. Insertion order is allowed. I mean, insertion order follows. I mean, yes. So thread safe, no. Array list is not thread safe. More than one thread can access. So when to use, if a frequent operation is accessing elements from the collection, and resizing mechanism. So when number of elements exceeds the capacity, default initial capacity is 10, right? If the size is exceeds 10, I mean, if you are trying to add 11th element, immediately it will double the size from 10 to 20. So if elements again, if one element you can remove, then again size will be shrink from 20 to 10. So that is the advantage of collections. Size can grow and decrease depending on our requirement dynamically. So time complexity for accessing the element is big O of 1. Why? Because array, right? For accessing elements from array directly by using index we can access, right? That's why big O of 1. And constant time complexity for accessing elements. So time complexity for insertion and deletion, it will be big O of n. Why? Because so if you are trying to insert, I mean, element at a middle position or n minus 1 position, shuffling is required. That's why it is taking big O of n time complexity. And moreover, the deletion also big O of n. Why? Because if you are trying to delete 0, imagine if you have 10 elements. So if you are trying to delete 0th index, in that case, maybe if you are trying to adjust the array, so all right hand side elements will be moved to, I mean, one step forward, right? I mean, one step backward. So in that case some shuffling is required, right? So that's why time complexity is big O of n for deletion also. So memory overhead, I mean, requires additional memory to store unused capacity of array. So here I already said, so if you are trying to add 11th element, it will create double size. I mean, array size, I mean, capacity will be 20, array will be created with memory locations of like 20 locations. So in that case, so My requirement is I want to store 11 elements, but remaining 9 elements memory will be wasted. That's why 12th point is saying about memory overhead requires additional memory to use unused capacity of array. That is about memory overhead. Now let me show you the documentation about list. So, and moreover that some questions, frequently asked questions I prepared here. So if you know any better questions along with this, make a comment in comment section. So now let me try to create array list. Then I will show the documentation. So first we need to create list. Array list also you can assign. So that is the, if you watch inheritance, parent reference child object possible. So that's why list is the parent of array list. I mean anyway list is the interface, either it may be interface or class we can create reference, but object is only for classes we can create. So I am trying to take integer l new array list. Now, if we can observe here, these diamond brackets are for generics. So, why generics are introduced to provide the type safety and type casting. So, if I can remove these generics, I will get anyway some warning, but that is not recommended. In 1.5, to overcome that problem, only generics are introduced. So, if I can declare the list without generics, I can add any type of elements. So, there is no compilation error. If I can add one, I mean, that is the integer data. Then I can add string. This is the string data, and then I can add l dot add true boolean data. So this is not good programming practice, right? So to overcome this problem only, in 1.5 they introduced generics. So if I can declare with generics, I need to specify only that type of elements only I can add. Otherwise, if I can add other than that type, I will get compilation error. And moreover that, here at the time of accessing elements from this list without generics, I need to typecast on my own. I don't know, right, which type of element at what index. That's why we need to typecast our own. So but if we can use generics, so you don't need to typecast. That is the advantages, type safety and typecast. These are the two advantages once you can use generics. So generics type, I mean symbol will be less than and greater than. Inside in between that you can specify your data type, either it may be integer, character, boolean, or your custom class also, employee, student, whatever it may be, you need to specify. Now I can add, there is no warning now. So I am trying to add elements. So l dot add, if I can add string here, I will get compilation error, incompatible types. I mean add is a method of integer type not applicable for string. So this is the compilation error. So note that clean code, I am declaring list of integers, only integer data only I can add into that list. So that is about generics. Now let me show you the documentation about list. So list is list is a interface that extends the sequenced collection. So sequenced collection is recently introduced in jdk 21. You are seeing, right, since 21. And its a list parent, I mean sequenced collection parent is collection. So collection parent is iterable. So this is the root interface, right, from all, I mean collection classes, I mean list, for list and set. So color root interface is iterable. For root class for entire Java is object. Root class for exceptions throwable. Root interface, here we can't say class, it is the interface, iterable. Root interface for all collection classes or interface hierarchy iterable, which is having only one abstract method called iterator. So from this method only, I mean, if we can observe 1.8 for each, so many methods are introduced internally, iterator only. So I will show you the documentation. I mean, when I wrote the for each method. So iterator method returns iterator of type T. T means data type. I mean, what type of data you are trying to specify here. So I already said, right, at the time of explaining in whiteboard. So T is type, K is key, V is value. These kind of some terms. When you are working with generics, be aware of these kind of terms. T is for, I mean type, what type of data. So and remaining two default methods will be there. One is split iterator and one is for each. So internally anyway for each also uses this I mean enhanced for loop. Now let me try to explain about, I mean list remaining questions as well. So that is about collections hierarchy. So from list to iterable. So iterable is the root interface. From its child is collection and its child is sequenced collection, and remaining list anyway we are using here, right? Now let me try to finish remaining points. So remaining point mean here I already prepared some questions, right? One by one I will finish it. So how to create array list? Like this you can create it. So now if we can observe here, I did not specify the capacity. Now let me try to explain about default initial capacity about list. So if I can go to this array list, so I will show you that default initial capacity where it is declared here. So you are seeing, right, default initial capacity is 10. That's why I declared here. Second point is default initial capacity is 10. So that is about array list, I mean default initial capacity. Let me try to finish remaining questions as well. I mean next question is how to add elements into an array. Like this here I already added, right? Now let me try to remove that white space. So this is the creating array list. I mean how to create array list by using list interface. L new array list. So this is the default initial capacity. I did not specify, right? So if you did not specify, default initial capacity will be 10. If you want to specify, you can specify here. You can override the default initial capacity 20 like this. So some constructors are there. Let me show you that. So here this is the default constructor with the default initial capacity 10. So and moreover this constructor is directly you can add element instead of adding L dot add. Directly you can pass to constructor values. You can add it. And the next one is these are the ensure capacity. When I think we need to decrease depending on our requirement. You can increases and decreases, right? This will be applied internally or we can apply on our own. So this is the size, how many elements are there, is the collection is empty or not, contains, index of, index range. So anyway my intention is to show you if you can declare the array list like this, default initial capacity will be 10. If you want to override, you can override like 25 or 20 or 50 or 100, whatever it may be, you can declare. That is about important points you need to remember about how to create array list and moreover the default initial capacity. Now how to add elements into an array. So L dot add. So by using add method we can add it, or else one more method will be L dot add all. You can add more than one at a time. So but you need to wrap that in a collection, not individual values. Like this you can't add, you will get compilation error. So first we need to wrap that inside a collection, then only we can add it. Either it may be arrays dot as list or list of factory methods that was introduced in Java 9, right? Now let me try to show you arrays dot as list. Arrays is a utility class that exists inside arrays class. I mean as list is a method, that a utility method that exists inside arrays class. Now I can declare values here. There is no compilation error now. So all elements, more than one element I can add at a time by using add all method. So duplicate elements are also allowed, right? Let me try to add duplicate 10. So this is about how to add elements either by using one at a time or all at a time you can add it. Now how to access elements from array list. So how to access elements from array list? So if you want to access by using index also you can specify, or using one, if you want to one by one you can use for loop. Now let me try to print all elements at a time. So L I am trying to print. So insertion order is allowed, right? First I entered 10, then 20, 30, I mean 40, 10 again duplicate values. And moreover let me try to add a null also. So null values also array list allowed, right? So I can add one more null after 10. So now let me try to observe the insertion order. So insertion order also allowed, duplicate allowed, and null values allowed. These are the some important points. And moreover that how to add elements, how to access elements. So either by using index. So line number 41 I printed all at a time. If you want to get specific number, so have method called get. You need to specify the index. So if I can pass index to, so what is the element at index 2 is 20. Yeah, 20 element. So what it will happen if you can pass that beyond, I mean that does not exist. So you will get index out of bound exception. Why? Because here we have elements like only 1, 2, 3, 4, 5, 6, 7, 8. 8 elements are there. If but you are trying to access 20th element. So the size, I mean length will be 7, but you are trying to access 20. That's why you are getting index out of bound exception. This is the point you need to remember. So if I can access, if I can find, I mean provide value as a 7, I will get value like so. Here index out of bound exception 1, 2, 3, 4, 5, 6, 7. 7 means index is starting from 0. That's why we got even 7 also index out of bound exception. If it is 6, null. That is the not, I mean last value of null. So array index is starting from 0. That's why even 7 also won't work. So how to access elements by using index number with get method. And moreover that if you want to access one by one, let me try to explain one by one, I mean three ways: by using iterator, by using for loop, by using for each loop. So let me try for each method. Now let me try to explain about iterator. So iterator is having one method called, I mean iterable is having one method called iterator, right? Now let me try to apply that iterator. So iterator is a method that exists inside iterable. So iterable is a interface that contains one method called iterator. So that method only, anyway this is the root line, I mean root class, root interface, right? This method by default available all its child classes. So anyway ArrayList is child class of iterable, right? That's why that method is by default available. When I am applying with the ArrayList reference, that method is I am getting without any compilation error. Now I am trying to I mean assign to iterator of type integer. So that's why here type means what type of data, T means what type of data. Here in this case integer type of data. That's why I am getting iterator of integer. Now let me try to print one by one. So for this I can use while loop. Why? Because by using has next method, how many elements in that list I don't know. That's why we need to use while loop. So iterator is the reference variable name dot has next. If a next element is there, then only print it, otherwise don't print, I mean stop it. Iterator dot next. Now cursor will be moved from one element to another element until last. So here I am getting element one by one at one by one from begin to end. This is about one approach to access elements from list by using iterator. Next one is by using for loop. So anyway we know, right, already from if we are learning core Java. So for loop have initialization part. Next one is condition part. L dot size, how many elements are there, and I plus plus. Now try to print it. So L dot get of index. Now let me try to run it. So I got two times. Why? Because from 10 to null. Why? Because anyway at the time of list of 6, right, get of list dot get of 6, I am getting last, I am accessing last value. So from 10 to null is the one iteration, 10 to null is the by using iterator, by using for loop. So if you want I can make it as a separator. So for loop, for loop iterator, and the last one is for each method, I mean for each. This one is the latest one, I mean that introduced in 1.8. Now let me try to apply list dot, I mean reference for each, which is expecting consumer functional interface. Now let me try to print the element one by one. So element E, I am trying to print it. So this is very simple. Now let me try to run. So maximize the output. By using iterator, I am trying to access from begin to end. By using for loop, by using for each method. Three ways we can access elements from collection. If you want only specific element, by using index. That is about accessing elements from array list. How to remove elements from array list. L dot, so remove, you need to specify the index. I want to remove at index 6. Now let me try to observe the output. So if I can print that list again, then we will get the. So let me try to print before and after. So before it will be null will be there. I am trying to remove index 6. That's why last null is removed. Removing elements by using remove method and with corresponding index. Next one is check the array list contains specific element or not. So to check that element exists or not, we can use list dot contains. Contains method is expecting object parameter, right? If it is there, it will return true. Otherwise, it will return false. Now let me try to apply. I mean, like I want to check 15 is there or not. No, it is returning boolean type, right? Now let me try to print that result. So contains. So 15 is there or not? So 15 is not there. That's why it is returning false. So if I can apply 10, 10 is there or not? 10 is present. That's why we got true. So to check the element exists or not, we use contains method. Next one is how to get the size of the array list by using size method. At the time of using for loop, I already explained here. So anyway, if you want, I can add one more thing. S out L dot size. Now size will be, previously it will be 7. Now I think it will be 6. Why? Because one element we already removed, right? So that's why we got the size is 6. Next one will be iterate through an array list. So anyway, I already explained on here, right? By using iterator, same reference you can take it. So let me try to copy this. So how to iterate elements from array list means by using iterator. So let me try to rename that variable name to avoid compilation error. Duplicate variable name. Now let me try to run it. So I got the mean same result, right? From 10 to, I mean, duplicate values also here we have, right? So from 10 to null. So that is the iterating array elements from begin to end by using iterator. So how to clear the elements in from the array list? So how to clear means we have one of the method called l dot clear. I mean reference variable collect array list reference dot clear. It will clear. Now let me try to print that size before and after. So here let me try to make some separator clearing. So previously it will be 7, after clearing 0. By using clear we can clear. So next one is to check the array list is empty or not by using is empty method. L dot, I mean object reference of array list is empty. So if it is empty, return true. Now it will return true. Why? Because now that is empty. Why? Because we cleared already. Now it is empty. How to convert array list to array? So if you have array list, if you are trying to convert, we can use list dot, I mean object reference, array list object reference to array. See here some overloaded methods are there. To array, it will return by default object array. To array into function, you can pass some whatever it may be, I mean functional interface. Next one is to array of type t. So if you can pass to array, it will return object type of array. Next one is l dot to array. If you want to specify what type of array, you can specify. So I want to specify. So integer type of array I want. So for that integer, I am trying to provide reference new constructor reference. So the method that is, let me try to one more time, apply one more time to array. Now integer. So we need to specify that array brackets, right? Otherwise, how it will identify? So to convert array from array list to array by using to array. It will return object array. If you want to specific type of array, you can specify here. Here I am trying to use constructor reference for integer variable class. So this is about array list. So some important points you need to remember. Underlying data structure is dynamic array. Default initial capacity is 10. I am saying about array list. Duplicate elements allowed. Null values allowed. Insertion order yes. Thread safe no. When to use frequent access. Resizing mechanism double the array when exceeds the capacity. Time complexity. For accessing big O of n. Why? Because by using index we can access. So time complexity. Anyway, shuffling is required for insertion and deletion. Memory overhead. So if there is unused memory space will be wasted for so when if requirement is not up to full capacity of the array, so some memory locations will be wasted. So that is about array list. So next one is linked list. So linked list also I created some points about linked list. So same as it is. So whatever applicable for array list, same applicable for linked list also, but except some points here. So in underlying data structure for linked list is doubly linked list. So here underlying data structure is changed. Now default initial capacity also changed. Why? Because if it is linked list, capacity is not required. Why? Because depending on our requirement, nodes will like chain, next it will increase. So duplicate elements allowed, null values allowed, following insertion order yes, thread safe no. When to use, when frequent operation is insertion and deletion. Why? Because so when you are trying to work with the linked list, when you are trying to insert, you can specify that links previous node and next node. And the deletion, current node links will be deleted. For current node, previous node link will be pointed to current node next node. So if you are aware of data structures and algorithms at linked list, then you can understand very easily this one. So resizing mechanism. So when number of elements exceeds the capacity. So here there is no default capacity, but I think this point is not applicable. So resizing mechanism is not required. Why? Because this is the linked list, right? Resize is not required. Depending on your, if you want to delete it, the size will be shrink automatically. So time complexity for accessing is big O of n. Why? Because here random access is not possible. Why? Because always a sequential access. You need to follow. If you are trying to, if you have array of linked list of 10 elements, if you are trying to access ninth index, you can't access ninth elements directly. You need to traverse sequentially 0 1 2 3 4 5 6 8 9, like that you need to traverse from 0 to end of the array. So that is why time complexity for accessing is big O of n. For time complexity for insertion and deletion is big O of 1, very easy in linked list. So memory overhead requires additional memory store the references. So when compared to array list, linked list requires extra memory. Why? Because for array list, storing the element only one array position is required. One index is required. But in linked list, the linked list node have two, three, I think two node, one node have two parts, right? One part is for data, one part is for references. Moreover, this is double linked list. So previous node reference, next node reference, that's why it requires more memory. So this is the previous point, 12th point, context only. Anyway, I will commit this code on GitHub. I will provide the link. You can note that all these points, or else you can pause the video and note that these are some important points at the time of interviewing. When you are trying to attend interviews, so these are the some different difference between array list and linked list. And moreover, that someone will ask about what is can you explain about linked list? These are the point you need to explain. So main difference between array list and linked list is underlying data structure for array list is dynamic array, underlying data structure for linked list is doubly linked list. So default initial capacity for array list 10, here not applicable. Duplicates remaining all points almost same except time complexity. And moreover that use case, when to use array list, when to use linked list. Frequent operation is access, go for array list. Frequent operation is insertion and deletion, go for linked list. Enough. Now let me try to explain about documentation and some important questions about linked list. So let me try to create the linked list first. So for linked list also, parent is list. We can create parent class reference, child class object. Parent class reference, here I am trying to provide string. So linked list, new linked list. Now let me try to show you the documentation about linked list. So linked list also extends abstract sequence list, anyway implements list. This is the interface. So a list again from sequenced collection, same collection iterable like this. So whatever methods applicable for array list, same methods applicable for linked list also. Why? Because all methods that exist inside iterable collection, sequenced collection, abstract collection list, these kind of methods by default available in its child class. Anyway linked list is child class of all these interfaces, right? So that's why say, all methods like how to add elements by using add only, so how to access elements by using get only, how to remove elements clear, how to check the linked list contains specific element contains, how to check the size of the linked list by using list.size, how to iterate the linked list by using iterator for loop or for each, how to clear elements from linked list.clear, how to check the linked list is empty or not, how to convert linked list to an array dot to array. Anyway I explained here, right? Same whatever applicable for array list as it is you can follow. So only one part you need to remember, how it will work internally. That is the point you need to understand. Otherwise, almost array list and linked list almost same, even vector and a stack also. But anyway, all those are thread safe. But array list and linked list are not thread safe. So if you want, I can write quickly. I mean fast. I mean for time saving purpose, I am trying to. You can add. What is this? So here it is string, right? Here I am trying to provide, that's why I got the error. Java. So like this, add all also there, like ll dot add all, add first, add last, so many things are there. So if you want you can play on your own. So I am trying to pass list dot of factory method I am trying to use. So Kotlin go like this, n number of elements also you can add. So add all at a time. So if you want to print it. So ll. So I got the elements, right? These are the elements I added, one at a time, more than one at a time. So like this. So elements, how to access, ll dot get of index, zeroth index is element is Java. So how to remove, l dot clear, ll dot clear, how to remove elements. So l dot clear only. So if it is how to clear all elements means clear, how to remove we can use clear means it will remove it will remove all elements. If you want to remove only one element, by using remove, by using along with index. So how to check the linked list contains specific element contains, ll dot contains. Anyway almost all same. I will anyway this is the string, right? I can pass string. So like this you can play on your own remaining as well. I am now this, I am trying to go for, exit for next collection class, that is a stack. Anyway remaining these three questions, remaining pending questions also you can try on your own, like array list. Next one is stack. So stack, for this one also I created some important points and questions, same questions here. This is stack here. So stack is for stack underlying data structure is dynamic array. So let me show you the documentation first, then I will explain. So how to create object for stack. So stack is from java.detail. So stack also child class of interface, list. So here I am trying to take character. Previous for array list I took integer, linked list I took string, stack I am trying to take character. New stack. Now let me try to show the documentation about stack. Stack extends vector. So first I need to explain vector, then I will explain stack. So let me go for vector. Why? Because vector is, I mean, child class, stack is child class of vector. Just now we saw, right? We try to close all. So array list, linked list done. Now let me try to explain about vector, then I will explain about stack. Why? Because stack is child class of vector. If we can understand vector, then stack is very easy. So in stack we have some extra methods along with vector. So here I already created some points about vector also, like linked list and array list. So underlying data structure is dynamic array. Default initial capacity is 10. Almost same vector and array list, but vector is synchronized, I mean thread safe. That is the one point you need to remember, except remaining everything same. How to create vector object? So one point you need to remember between array list and vector. Vector is thread safe, array list is not thread safe enough. Vector is legacy collection, array list is recently 1.2 introduced in Java 1.2. So how to create object for vector? Vector by using vector class v new vector. So every method present inside that vector is thread safe, I mean synchronized. Let me show you that. So vector, so this is the default initial capacity 10. Here they are initializing with default initial capacity constructor. So vector extends abstract list. Again parental, I mean implements list. List parent sequenced. Sequenced collection parent collection. Collection parents iterable. So same again. So whatever methods applicable for list, iterable, sequenced collection, all methods available in vector also. Same. How to add? V dot add. So why? Because v dot add method is by default available, right? So we can add like this. So vector, how to access elements? V dot get, v dot clear, v dot remove, not clear. If we can apply clear, it will remove all. If you want to apply remove with index, specific index. How to check with the vector contains specific element? Contains. How to iterate? By using iterable. Iterate method is having, iterable is having one method called iterate, right? By using iterate for loop for each method. By using clear, how to check whether is empty or not? Is empty. And next one is vector convert to array, to array, v dot to array, almost same. But one point you need to remember is internal data structure, how it will work, when to use, enough. Next one is stack. Now if we can observe the stack about, I mean underlying data structure for stack also dynamic array. Default initial capacity also 10. And difference between vector and stack is, so almost all are same, but insertion order follows like LIFO, last in first out. But vector is, I mean order as it is follow, but here last in first out insertion order. Why? Because stack, right? So when to use? If our frequent operation is last in first out behavior. So resizing mechanism similar to array list. Time complexity, push and pop, I mean adding and removing, it will take big of n. Why? Because always we can add element on top, always we can remove element on top. That's why it will take big of one time complexity. Memory override similar to I mean vector and stack only. I mean currently this is stack, right? Similar to vector. So remaining methods as it is same. Whatever applicable for vector applicable for stack. But in stack some extra methods are there. So let me show you that. So here you are observing, right? Stack extends vector. So all methods that exist in vector by default available in stack. Along with that some extra methods like push, pop, peek is empty, search. Anyway, this is the variable. So push method can be used to add the element into inside tag, I mean stack. Pop method to remove. Peek means I mean don't remove but return the top element. Is empty to check the empties, I mean stack is empty or not. Let me try to add that, I mean write that methods. V dot push, not add here. Anyway add also there, I think. Let me try to show you. Why? Because add is there on vector, right? That's why it is inherited from parent class, I mean that is vector. By using add you can add method, you can add into stack element or push, that is from stack. So character, I am trying to push a. push method used to add, and how to access elements by using peek. Always you can't access elements at random, or I mean always you need to access element on top, always you need to remove on top. There is no need to random access, random remove in stack. That is the default behavior of stack data structure. So peek apply, you mean how to access element. So what is the difference between peek and pop? Peek, we want to remove the element from the stack. Let me try to show you that. So A, B, C. Now let me try to print that size of the stack. V dot V dot, I mean stack, right? S dot size. Now I can, so now let me try to print that. Control X, V. Now I am trying to access C, I mean top element is first pushed A, on top of A, B, on top of B, C. Now I am trying to peek means last element. Before and after size is 3. If I can apply pop, it will peek, it will return the element, but it won't remove. Pop will remove and return. Now observe the size. So previously 3. Now pop, pop will remove and return. Now size you can observe 2. That is the difference between pop and peek. Next one is remove elements by using pop. How to check the contain specific element? Contains, yes dot contains. So that exists inside vector. How to get the element? Get. How to get the size of the stack? By using size. How to iterate? By using iterator. V dot clear, s dot, I mean stack dot clear method. Check the contents, stack is empty or not. Convert stack, I mean to array, by using to array. So these are the methods that exist inside stack. And moreover that I explained all list interface implemented classes: array list, linked list, vector, stack. So one point you need to remember among all these four. So almost all are same, list implemented classes are all same, but when to use which collection you need to understand. That is the one point. And moreover that try to write down these important points. I make already note, right? Anyway, I will commit the code on GitHub. They can take it, or else you can pause the video and you can write down on your, I mean pen and on your own book. So I hope you got some clarity on list implemented classes, array list, linked list, vector, stack. So if you like the content, hit on like button and subscribe Programming KT. Thanks for watching.